Gracias, Taro.
It's fine. Can we start? A este paso, sí. Okay, can we start? I think I want to finish this soon, so. Well, okay, let's going to start. Thank you for coming. So, okay, the chat is divided basically in 4 parts. The first 2 are going to be a little bit light, so stick to me. The second 2 parts are going to be more dense, and that will be more interesting. So, on the first part, I want to study what is a paradigm. So, I think the best way to study a paradigm is just by saying an example. So, what's the length of a circumference? What you will tell me? 2 times PR. Okay. What are the tools you will need to compute the length of a circumference? A calculator. Okay. So if I give you a calculator and I tell you, okay, then tell me the length of the circumference, how will you do? That's the point. You cannot. And the problem here is that you are thinking about mathematical paradigm. The mathematical paradigm is all about formulas, computations, and calculators. While here you are in another one. Here you are in a screen. So you may need a ruler, a pen, and a compass. Or it can be even something harder. You know, you just can have a cylinder, a bottle. And someone wants to say, what's the cylinder of the bottle, right? And you may need a rope. So there are different ways of thinking. So, sit down here. Okay, so there are different ways of thinking. So for the same problem, we have different ways of attack the problem. So when it's about programming, you have the same things. You have the tools, and you have how you use your tools. In this case, you have the functions, the object, the class, the structures, and then how you combine them. You just have assignation, you just have functions, you have predicates. So one very, very important thing that whenever you're going to start programming something is you really need to learn the paradigm. So I have put a few examples of object-oriented paradigm, as most of you are going to be using it. So just look at the example, try to tell me where is the error. If you return, the file will not be closed. That's not the error. The error is the paradigm. You're using imperative when you should be using objects. When you are programming in object-oriented, all the resources must be an object. That's one of the rules. So the way you will have to do this is the file to be a class. So whenever you return, the file will go out of the environment, the file will destroy, the file will get closed. It is. I put the example. If you have a locker or you have a semaphore, you're going to have the same problem. The semaphore, in one of the moments, you need to wait for other people to enter. So once that is your turn, you will go inside. Once you go out of the critical section, you will say, I'm out of the critical section. You will post. But here is a problem, the same as before. You can't return in the middle. So again, you will break the things. So how can you solve this problem? How this object-oriented will help you to solve this problem? You can create a resource manager. So a resource manager, it can be an object that it takes care of another object. So in this case, you create a mutex. A mutex will be valid while you are in the environment. Once that you go out of the environment, the mutex will die. And when it dies, it will free the lock. You get it here? So it's very, very important. You need to learn the paradigm. Later, in another part of the chat, we will see something about the paradigms, something about object-oriented and what are the common mistakes people are saying about object-oriented. The second part of the chat is about methodologies, why we are going to use them. So I want you to think, for example, in this case, you have a piece of paper and you are writing a polynomial there. And now the teacher says, you know what? The polynomial has 1 degree more. Sorry, guys, I forgot. How will you fix the problem? You usually will do something like that, right? You didn't know the point? If you are writing in the piece of paper you have, and you start writing the polynomials just in the left corner, you start writing 3x squared plus 5x plus 7 or minus 7 equals 16. Then the teacher tells you, oh, I want the polynomial to have more degrees. I want to have another term. You don't have a space to write this term. So you will have to do some kind of fancy line there to say, you know, we got this problem. Okay. The people who is working in algebra don't write polynomials in this way. In fact, they write it in this way because space to keep adding terms. I'll give you another example. A plus bi, where I is the square root of -1. Till this moment, you probably all see this one. And you will say, eh, it's fine. But the curious thing is that some people just write it like this. And you will say, this is very rare. This is very, very strange. Why they do like this? The reason is, when you change two numbers, the number 1 and the I are very close together. So it's very easy to make a mistake here. So if you use the J is always under the numbers. So if you're writing complex numbers in this way, the brain will have you to identify quickly what are the complex part of the number and what part is the real part of the number. More and more. When I was studying chemistry, the teacher always was telling me, you know how a person knows chemistry if in the way he writes, he left spaces between the symbols, in this case, the notation of the molecules. Once you write reduction, you will need a space to put numbers in the equations. Otherwise, you will be making, how to say, blurry things on the screen. So why we are using methodologies? There are mainly 3 reasons. It helps us to keep an order on the things. It helps us to make less mistakes, and it helps us to reach a goal. Sometimes the reaching a goal is a consequence of the previous 2, but sometimes it's not. So whenever you're going to follow methodology, even you don't fully understand what this methodology is saying, just follow it, apply it, make it yours. Once that you have been using it, then you will be able to master, and you will be able to what's good and what is not good. So here, it will come soon, and we will start studying DDD, TDD, BDD, and so on. And maybe at the beginning they don't make a lot of sense, but once that you start using them, even when it's then you just this methodology. So metrics of good code. What are these things? This is a way of deciding when a program is well written. And probably all of you already hear about these ones. They say, avoid duplication. Duplication is a very bad thing. Try to have a very high cohesion in the program. I mean, things that are together should be together in a module. Try to have low coupling. I mean, interact too much with each other. Okay, that's fine. That's the how. But I mean, that's the what. But let's see a little bit about the how. Avoid duplication. Also, they call it the drive principle. Don't repeat yourself principle. You may think this is kind of new. This was by Andrew Hunt. It was in the 1999. So we're talking about 15 years ago. So I don't duplicate code. I never copy and paste the code. Okay. What about the comments? The comments that you write in the code are saying exactly the same as the code. Or if you have database with tables, and one of these rows to transform into an object. That's duplication. If you are using a graphical user interface and you have one tool to define the graphical user interface, and then in the code, you need to go and type what's the ID of this or that, you are duplicating. If you are reading input file, and from this data, you just take a subset of data and you pass it to another function, you are duplicating code. And one case here, the structure. You have a structure with 2 points, and you also save the length in the structure. So if you modify the point, the length will not be updated. Duplication of code. So the duplication is not so simple as just copy and paste code. The duplication is scattered all around the code. So there are a lot of good practices here that you should follow when you are trying to do the programming. This at the end, I will tell you a book that explains this very well. So I highly recommend you to read this book. Cohesion. The cohesion measures how well the module fits. It was invented by Larry Constantine at the end of the 1960s. I think I don't remember wrong. It was 1972 when they just published the first book about this. In this case, remember the paradigm. I mentioned to you, one of the rules in the paradigm of object-oriented programming is that all the resources are an object. Memory is a resource, so memory should be an object. C++ allows you to create things and asks you to delete the things. How this could be an object? The way is make a class. In this case, they already have one, the standard template vector, and use it. Think about testing. If you would do the code as in the top part, how will you run a test that for each memory allocation that you have, you will free the memory? The only way is encapsulating the things, making an object. So at the beginning, some people will tell you all the resources are an object. In the say, what happens is there is high cohesion here. All the resources have high cohesion. All the resources create, allocate, and free. So it makes sense then to be an object. You don't need to use the heuristic anymore because you know the real reason. But that is what you need to do when you have to start working with methodologies, or heuristic in these cases. Coupling. This was invented by the same guy. They invented together. Low coupling between modules. Everyone mentioned. And that's the easy one. There are a lot of different couplings here. I will mention just a few. I mean, you can go Wikipedia, study them better. So, for example, the common coupling, it can be you are sharing a global variable. So whenever the sharing variable changes, these modules are affected. You can have an external coupling. For example, different modules depends on an outside resource, like a file. You can have control coupling. You have created functions, and one of the arguments is true, false. Depending on this true, false argument, the function will do one thing or it will do another thing. Stamp coupling, what this we were mentioning before. You just take a structure and then you use only part of the structure. So, for example, you just get one module to pass the structure to a module B, and the module B use this structure, this field. It would be better if you directly pass the field, don't pass the structure. If you later want to rename the name of the structure, you can keep it on the module A. Module B does not need to know that A was renamed. You follow the idea? Well, message coupling, well, this is very low. So when you are sending messages, of course, if the message changes, the other part needs to change and so on. For subclass coupling, that means that derivative class to the parent class. And, well, temporal coupling, I don't think this is very important. The temporal company is about all the things being in the same module just because they have some relationship. All the shutdown code, I will put it in this module, but maybe probably has nothing to do with this, you know. So, Connascence. Well, this is the most modern of all the things, or no? Let me check it out. This was created by Mailer Patience in 1992. I hear about these guys because there was a chat, The Grand Unified Theory of Software Design by Jim Weyrich, or Weyrich, but I don't know how they. I think they use this name because the name couplet was taken. Connascence means that the things are bound. So the very interesting things about Connascence are two. First is what they define as locality. So, for example, you have a Connascence of name. You have a function, and the function has different arguments. Each argument has a name. When you rename the argument, you need to change all the instance of that argument in the function. So the locality is the function. If you change the function name, then the locality will be the module or the other modules that are using this function. If you change a global variable, then all the modules who use these global variables need to be updated. You can have, well, the same for the type, cohesion of type. The interesting thing of cohesion is also the order. The number 1 is the lowest one, and the number 9 is the highest one. So if you have some kind of constants of one type, you always can reduce to the previous type, or you just maybe are able to find out what it would be the previous time. So, for example, you may have an array, and all the arrays, you know, the position 0 is the name, position 1 is the surname, position 2 is the second surname. So you have constants of position is number 4, but you can move it to constants of meaning. For example, you will be able to say, instead of having this array, what I'm going to do is to have an object, and when I just call the name, it returns me the real name, and surname, the real surname. So you may be able to have to transform this array into an object, but it will reduce. It will be harder for you to screw up the things. If you just change the order in the array, you just change in one place, the object keep going fine, and all the rest of the people who is using the object will not screw up. Here you follow. Let's see all this together, okay? This is when we are just going to try to put in practice all these kind of things, and when we're going to start studying the methodologies. Simple problem. I have a URL, and after the question mark, there are some arguments. I want to have a function that gets or gives me the arguments of this URL. How will you do? Will you start writing the functions quickly, like this? Get args of URL. Maybe you fill in, then you do some tests. Just writing this, the get args of URL. I want you to think how many mistakes you have done. Just for a second. How many mistakes you have done? If you get a formula that is the number of mistakes divided by the number of things that you have done well, you will get infinite. You did not do anything well, but you do a lot of mistakes already. So this is where we have to think. Don't start writing code so directly. The first thing that you need to do, domain-driven design. Domain-driven design is very good at fetching what they call the user requirements. The important thing here is that you really need to understand with what you are working with. In our case, they are not called arguments. If you study the scheme or the reference of a URL, they will be called query. So you are starting to call it arguments. And the model, that is the URL, will be the same query. You are starting to talk a different language. Some of you have been working with icons. What the icon do? It sends, it transmits, it signals, and what does do? A message, a signal, what it does, it sends a message or encrypts a signal. Start talking the same language that the domain does. The beautiful thing of domain-driven design is that it will allow you to establish all these kind of domain structures. It's like a UML diagram, and then it will tell you how nicely you can translate this into objects, keeping all the reference to each other, keeping all the constraints the domain has. So if the code really cannot do, then the domain cannot do, and vice versa. So you need to put a big effort on trying to put the restrictions of the domain. People not to screw up the things. The second thing is test-driven domain. The test-driven domain, the beautiful part is at the beginning, you can start designing. Instead of getting a piece of paper and write how things will be, try to do test-driven domain. I mean, this is very hard at the beginning. It's very good if you just try to use some gamification going on here. So in this case, for example, the framework that you will use to run the test, so it will provide some positive feedback, green light, a sound, a message. Just try to get attached to that message, because when you don't get it, you should feel itchy all over the body. You should really feel, I need to fix this one. In our case, if we just start defining the simple program that we have, get query for this input, I want this output. So what we need to do next is first, let's make this work. Very simple, even if it's fake. Now you got green light. Now you can modify this one in order to go for something that implements what the functions need to do. We go for our first implementation. It may be good, it may be bad, it doesn't matter, just do it. Something that works, it passed the test. After you go these steps, is the moment. Here you need to stop and think again. What are the namespaces? Try to make 3 levels. Really, 3 levels. Try to classify the things in 3 levels, at least 3. So website, static files, website, JavaScript. In this case, application, web, URL. When you try to put different levels, it will help you to organize the code. Don't leave it for later. Try to do now at the beginning. It will help you to create names easier. If you have to create something in the domain that is URL, and you have a constructor, you can say URL create, URL init, or build, or create from, or URL parse, or URL get query. You don't have to be thinking about strange names. If you are working with a language that does not really have namespace, use something like underscore or whatever you feel like, application underscore web underscore URL. If you have a tool that is going to be start completing, as soon as you start typing, it will complete for you, so it won't be a pain. Second thing, for the object that you need to be designed, you need to think, is this something that really needs for something heavy like an object? Or in the case of our URL, is something that you just want to call a function, give me this one, I don't want to keep this data. Or is something that's going to be a value object. A value object is an object in which you just put the data, but then later you cannot modify. So give it a thought. I want to separate it in this way, and then I want to be an object, I want to be data value, I want to be something like Namespace that will return a simple structure or just a result or exactly what. Decide setters and getters. Very important. Doesn't matter which one you choose. Doesn't matter. Stick to it. If I'm going to be reading your code and I see that everything is get underscore something, or you just wrote in camel, I took effort to read how you set and get the things. Just keep it like that. When I'm going to read another module of yours, I'm going to be expecting the same behavior. If I don't see the same behavior, I will start untrusting the code. Now you can apply test-driven domain, the second part, if it applies to you. This is, for me, more for object-oriented. You can help to translate all the model, all the relations that you got into the real model. And here is when we start having fun now. We get our function. We already thought the function. We only have to change the name. we just put into the namespace. Now, what comes next? Refactoring. And this is the key. So you want to write some clean code, the refactoring is going to be the key. It's going to be before and after. So 4 rules, you have them here. You need to make the test to cover 100% of the code. This is very important. If you don't do this, you will break, you will pay. Each function you are going to create during the refactoring, you will need to create a test. So here can happen 2 things. For example, you are eager to start dividing the functions. And then you say, if I start creating the test, I will lose my thinking thread about how we'll create these functions. Okay, go to the test, make a comment, and say, I'm going to call this function with this argument. That is what I have in the thread. And then keep doing the rest. Because later, when you're going to implement this function, you will not have the test in which you were thinking you would call this function. So you will try to make a very generic function. You will try to make a function that covers all the cases. You may not need it. You need a function that covers exactly what you need. No more, no less. You need to write the code in a way that will be your documentation. What this function does is in the test code. That's the way of documenting. It's just going to put a document. We will see later. It can be repeat yourself. Don't waste your time on those things. Waste your time on things that whenever you touch them, they're going to get broken, so you are going to have to fix it. Low coupling. Let's start by this one. We want to split down our function. How we do this? Demeter law. Already telling you how to do this, but really how to do this? There are going to be 2 kinds of functions you can write. The first one, let's call it one level, level n, is a function that is going to be administration. Level n plus 1 is the function that is going to be computations. In this case, you have an if with a computation. The code would be much easier if you put if function and the function has a computation. Again, thinking test. If you have to write a test case for this, how will you do? You will have to call the main function with several years, ones that are leap years, some that are not leap years. If you have it in this way, the function that do computation just have one test. The big one has another test. Tests are separated. You cover 100% of the cases. If later you find a bug and you say, oh, for example, in this case, you have year module 4 and you don't have the year module 400, how will you do it? You go to the test, you add this test case, the bug is covered. So it would be easier to do, testing all the previous bugs of the system because the test cases of the system already cover the bugs. I'll put you another example. This is, I took it from JavaScript. How easy it will be to write the function? If you write the function on the top, what you will write as a comment? No way to have this. Oh, I'm gonna return the array sorted alphabetically. Why you need to put a comment? Don't put a comment. Make a function. Say it with a function. Return array sort alphabetically. This is where the code is gonna be start simple. How we're gonna do the refactoring? Gonna give you some rules, heuristics. You can read more. First one, functions, maximum number of arguments, 3. Some cases, okay, I have vector in R4 because I'm doing a video game. Okay, take 4 arguments, fine. Exceptional case always. You want functions that has 3 arguments. When you are having 1 argument, it's easy. You can do a test. You have an input, you run the test, passing the function, you get an output. Very easy to test. You have 2, okay, can be done. You have 3, you are getting very hard function to test. More than 3, you can get mad. So if a function has more than 3 arguments, think, why it is this. The arguments has high cohesion. Instead of arguments, so I pass an object that handles those arguments. The function itself should be divided. Study. There is very, very few reasons I found that you need to use more than 3 arguments. Seriously, think for this and refactoring. It's going to be important. Separate error management. Whenever possible, use exceptions. It makes the code much more clean. It sees what you're going to do and not what you want to control. If you don't have exceptions, think about some kind of other mechanism you may have. Whatever, you create a login class and you pass this class, or you create coupling by making global and you keep annotation. Find out some way, but try to separate error management from the code. Think about this. Imagine that you, in the error management, you just display message to the user. If you will have to translate the application to another language, you would like this message to be all in one place. You will not like to be looking all around the code where to translate these messages. It's high cohesion. My error management has high cohesion. No comments. Really, try to avoid them. Just imagine if you just have Lord of the Rings and you write with comments. The little two hobbits goes into Mordor Valley. Footnote 1. Mordor Valley is a valley that is the super bad guy going there. They also get very tired. Footnote 2. There is a volcano. They feel very few oxygen. Of course, they feel tired. You don't want to rely that. You want the code to be telling your story. Avoid comments, especially these ones. They are all duplication. I will iterate all possible touch points. Well, that's what for does. Why you write it? Or add the view controller's view to the window and display. Well, that's what the code says. Why do you need to tell me? I mean, I can read the code faster than you code, faster than you comment. Avoid true-false arguments. This is the logic coupling we were talking about. If you do a true-false, you will have to duplicate your test cases. Case for one case when it's true, test for the other case when it is false. Let's see how we refactor the code following all these rules. The first function, management function. Try to say what the code does in very high level. I take the URL, I split it, I take the query, I process. How easy was for you to understand that one? Think about the next level. What is URL split? Well, I want to take the part of the hash till the end, remove it, the part from the question mark till the end, get it. That's the query. I would maybe in this function be tempted to write, oh, I also have the hash code. Why I don't return the house in the structure? Don't do it. You wrote the test, you need this function only for the query. Don't overwork. If later you just need to enhance the function, go ahead, do it. But for this moment, for this case, you only need the query. Why you need to make more complex structure? Just use what you need. Next function, convert the query to value object. The problem that you're going to be dealing here is simple. I have a query string, I convert to an object. That code is much, much easier to understand than the initial one. Because in the initial one, you really need to keep in mind where the string is coming from. How do you obtain the query? How I'm going to pass this one to the refactoring. This is very simple problem. I have the query string, I convert to an object, I return. There is no more, no less. Again, this function was created also level, I didn't say level. This is n+1 because it's doing computation with the objects. It was created for being able to understand the previous functions. You just get a map, you just call a function, so it is easy to read the code. I won't have to write a comment there. Document the code. What are the test codes that I have to do when I was doing these kind of things? It was 3 lines of code. Really, 3 lines of code. It was no more than that. If you read the test code, I mean, from the top to the bottom, what you will read is, you get a query, you split it into this, then you have a function that is able to split each of the elements. You have a function that for this string gives you an object. That's the documentation you need. How this function works, exactly like this. If you don't have a test code here, means the function was not thought for the case that you have it. So if in one of the moments you are programming, you say, it fails for this case, you go to the test code. If the test code is not there, the programmer did not think about that case. So you will have to enhance the code. You will have to write the text here, then you will have to start refactoring and first implement, then refactor the code in order to start getting the expected results. References. I recommend them all. Really, read them all. Robert C. Martin, also known as Uncle Bob, used to say we are awful. This clean code book, it gives you lots of heuristics. Very good book. You should read it. Some of these people don't really like some of the heuristics that he says. He says, well, you are putting here a lot of heuristics, but if you know the real principles behind, then you should really go and use the principles rather than heuristics. The heuristics sometimes mess up. Well, okay, fine. Eric, domain driving design, very important. He's brilliant. This guy is very good at getting user requirements. Very good. Just to see how he's doing conversations with the engineers. Just to see how, as long as you are trying to get into the model of the person that you're talking with, it will start you to drive you to good code, to good understanding between each other. Test-driven development, beautiful. It also tells you how you just can manage the things at the same time. What we were seeing here, you write the function, you write this. It does not talk about refactoring, but more or less he's doing natively. The pragmatic programmer. No comments. Read it. Simply read it. The rest of the books, you should. They're good too. Connascence, if you want to cite the presentation at the end, the guys explain everything. So